So today we're going to be browsing the rabbit hole of Wikipedia for a simple topic like calculus. So let's start. Already on English. Now we're getting some people. Okay, that wasn't. You can keep going in any direction. Last time I did this, I did not get into this direction. We're still on France. Now we're on etymology. Now we're on language family. Now we're in the definition of language, knowledge. Now we've literally entered. We've entered the deep end. See, now we've gotten to astronomy. Now it's hard to escape, but we have entered quite the rabbit hole. Now I'm just clicking random stuff. I actually don't know what I'm clicking. I'm just gonna get anywhere. Now we're in the Great Lakes. Now we're going to Superior. And now, let's look at this. What page have we got on sequence alignment? Let's see. In bioinformatics, sequence alignment is a way of arranging the sequences of DNA, RNA, or protein to identify regions of similarity that may be consequence of functional, structural, or evolutionary relationships between the sequences. Aligned sequences of nucleotide or amino acid residues are typically represented as rows within a matrix. Gaps are inserted between the residues so that identical or similar characters are aligned in successive columns. So basically they're just taking a bunch of proteins, they're taking the naming structures and putting gaps between them. This is like the language of like sequence in the amino acids. Sequence alignments are also used for non-biological sequences such as calculating the distance caused between strings in a natural language or to display financial data. Two sequences in alignment share a common ancestor. Mismatches can be interpreted as a point mutation and gaps as indels, that is insertion or deletion mutations. Introducing one or both lineages in this time since they diverge from one another. In the sequence alignment of proteins, the degree similarity between amino acids occupying a particular position in the sequence can be interpreted as a rough measure of how conserved a particular region of sequence motif is around lineages. The absence of substitutions or the presence of only very conservative substitutions, that is, the substitution of amino acids whose side chains have similar biochemical properties in a particular region of the sequence, suggests that this region has structural or functional importance. Although DNA and RNA nucleotide bases are more similar to each other than amino acids, the conservation of base pairs can indicate a similar function or structural role. So this is talking about this is very technical. This is about sequence alignment for amino acids. So you care about matching and mutations of amino acids, and they're talking about lineages and all this stuff. So this is non-conservative or not really great. That's what I got to know. Of mammalian histone proteins. Sequences are the amino acids for residues 180 to 180 of the protein. Residues that are conserved across all sequences are highlighted in gray. Below the protein sequences is the key donating conserved sequence, conserved mutations, semi-conserved mutations, and non-conservative mutations. So these are all conserved, and then these are semi-conservative mutations. And these are some non-conservative. It's non-conservative, and most of it's conservative though. Most of the blocks are conservative, but some are non-conservatives in the histone proteins. Anyway, so let's look at how far we're back. Levenshtein distance. Two strings A and B. A, B. For example, the Levenshtein distance between since the following three edits change one into the other. Kitten, sitting, 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 sitting. Oh, this is much more interesting. So we're replacing. Okay. So this is interesting. Levenshtein distance between two strings. So it's 3. It's 3 away. Sitting and kitten. Create the K to S. Change the E to I and add a G. Uniformed. Uniformed and uninformed. It is at most the length of the longer string. It is 0 if and only if the strings are equal. If the strings have the same size, the Hamming distance is the upper bound of the Levenshtein distance. Let's go to the Hamming distance for a second. The Hamming distance between two strings of vectors is the number of positions at which the corresponding symbols are different. Carolyn and Catherine is 3. Kaovi and Kirsten is 3. So basically how many are different, that's how the distance is. Okay, that makes sense because you just keep replacing and replacing. Okay, and now let's see everything else. String metrics. Oh, we went to Hamming distance earlier. Oh, we were in Hamming distance. And now we have all this. Now you might see some repeatings because I went through them. And let's go back to calculus. We didn't start the Western Hemisphere. Oh, where is calculus? Well, we started at calculus, but seemingly it's not here. Well, hopefully you guys have learned something like I did from today's video, and see you later. See you later.